Hello everyone. I am Dr. P. Magesh Kumar from the Department of Civil Engineering, K.S.Rangasamy College of Technology. In today's session, we will explore an essential concept in wastewater engineering, the types of solids in water and wastewater. Understanding the nature and behavior of these solids is critical for designing the efficient treatment systems. So let's begin with the term total solids. Solids in a liquid refers to any matter that remains after removing the water. Those solids can originate from various sources like domestic sewage, industrial discharges, or even the surface runoff. We classify total solids into different types based on the two criteria, whether the solids are in suspended form or in dissolved form, and whether the solids are in organic nature or inorganic in nature. So based on these criteria, the total solids can be divided into total suspended solids and total dissolved solids. Again, they are classified into fixed solids and volatile solids. And let's look at the first classification based on the physical order. Floating solids. These are all the visible particles that float on the surface of water or wastewater, like cork, wood, and plastics. And the suspended solids, the particles that are large enough to be filtered or settled out but not dissolved. For example, gravel, sand, silt, clay, algae, these are all called as suspended solids. And the very fine particles that remain suspended and can pass through any ordinary filters are called as colloidal solids. And the substances that are completely dissolved in water and cannot be seen with the naked eye, those are called as dissolved solids. Now let's classify solids based on the composition. Organic solids, which can be further divided into biodegradable like food waste and natural substances, and non biodegradable like industrial chemicals, and another classification is inorganic solids, which are typically minerals and salts. The organic compounds normally contain carbon and other elements also, and the inorganic compounds do not usually contain carbon. So the inorganic carbon compounds include carbon dioxide, carbides, carbonates, and cyanates, etc. And biodegradable organic solids include substances like starch, fats, proteins, alcohols, acids, and esters. These are utilized as food by naturally occurring microorganisms during the degradation process. The microbial utilization occurs through aerobic process in the presence of oxygen, which produce stable end products, and another another is anaerobic process in the absence of oxygen, which leads to unstable end products. So these processes are accompanied by the oxidation and reduction reactions. So biodegradable organics measurement. To measure the biodegradable organics, we use BOD, biochemical oxygen demand, we simply call as biological oxygen demand. This BOD indicates the amount of oxygen required by microorganisms to break down organic material in water. The standard measure is the BOD 5, or the BOD measured after 5 days at 20 degrees Celsius. The non-biodegradable organics are those that decompose very slowly or not at all under natural conditions. Example, tannic acid, lignic acid, phenols, detergents, organic pesticides, and industrial chemicals. These require strong oxidizing agents like potassium dichromate for breakdown, indicating their resistance to natural treatment process. For a complete picture of organic contamination, we use COD, that is chemical oxygen demand, which measures the total oxygen needed to oxidize both biodegradable and non-biodegradable organics. And total organic carbon is another useful parameter for measuring both biodegradable and non-biodegradable parameters. So here is how you can interpret. BOD measures biodegradable fraction. COD minus BOD gives you an estimate of non-biodegradable organic parts. So what happens to these solids? So let us understand how these solids are treated in a wastewater treatment plant. In the primary treatment, large and settleable solids are removed through physical process like screening and sedimentation. In the secondary treatment stage, the biological processes are employed to degrade the organic matter using bacteria, and in the tertiary treatment focuses on removing dissolved solids and polishing the effluent. In modern systems, some of these steps are combined for efficiency. So, to summarize, the classification of solids in wastewater helps us understand their behavior and guides us in selecting the suitable treatment operations. Thank you. Thank you for your attention.